In your kit, you got a membrane keypad. Now, most keypads you get, including the keyboard for your computer, are a matrix. Now, what do I mean by matrix? Well, let's take a look at the internal wiring of your keypad. I ripped one open here so you can see inside. Don't do this because it ruins the keypad. Let's say I press this key right here. It connects this wire to this wire. If I press this button, then this wire gets connected to this wire instead. Or if I press this button, this wire is connected to this wire. So as you can see, it's a matrix of rows and columns that are connected by pushing the buttons. Now, by building a matrix of buttons, they reduce the number of wires needed. This is a 20-button keypad, but we can read all 20 buttons using only 9 wires. So how do we read the matrix keypads? Well, let's say the user has pressed this button right here, the 9. So basically, we scan the keypad. We send a high out on either one of the columns or the rows. Now, I'll use the columns. So I'll send a high out on the first column. We then scan the rows one by one, looking for the high to be transmitted on one of the rows. There is no high, so we set that column low and put a high on the next column and scan the rows. Again, there is no high anywhere, so we set that column low and set the next one high. As we scan the rows, looking for a high, we see one in the 4th row. Because we were scanning with the digital inputs and outputs, we know which column was high and which row connected to that high. So we can now determine which button has been pressed. If no button was pressed, then all of my reads would come back as zeros. I just start the scan all over again, reading from the first column and first row. Now, the Arduino doesn't understand what is written on the keypad, see? Our keypads have numbers, a pound, a star, and even some control and function keys. That is all meaningless to the Arduino. The Arduino only understands binary numbers, that's it. As is typical with programming, there is more than one way to get the job done. So how you both read and deal with the keypad readings, I will leave up to you. I will walk you through what I did, just to give you some ideas and a starting point. What I did was I just set up a math function where each column equals a certain amount and each row equals a certain amount. So when the Arduino detects a button press, it simply makes a sum of the column value and the row value, which in turn gives a unique number for each key. I just make sure that my row and column values are in such a way as to make it impossible for 2 keys to have the same value. For instance, if I just give values to the columns 1 through 4, and then values on the rows 5 through 9, then this key, F2, would return a value of 7. The sum of the column value of 2 plus a row value of 5. But that would also mean that this key would also return a sum of 7. Look, it would have a column value of 1 and a row value of 6. So using these column and row values won't work. I'd have to make the row values a base number of at least 4 because I have 4 columns. So columns would be 1, 2, 3, 4, and then I'll make the row values starting at 5 and then increase by 4 each row. 5, 9, 13, 17, 21. If you had a keyboard with 8 columns, you'd have to make the row values skip by at least 8 at least. Now, before we go on, take a quick look again at the internal wiring of the keypad and the connecting strip. Notice the columns line up with the connector strip left to right, 1, 2, 3, and 4. But for the rows, the first row wire actually goes to the bottom row. Then the second bottom, third, fourth, and fifth. So bottom to top order. If you have a different keyboard or keypad, this wiring might be different. So when I wire the keypad to the Arduino, I could crisscross the wires between the keypad connector and the Arduino so that I scan the rows from top to bottom. But I am going to follow the present pattern because when I connect to the Arduino, it's just simplest if I go with the wires as they come out of the keypad connector. So you just treat the connector like a breadboard and throw some jumpers in there and then over to your Arduino. So doing it this way, obviously the numbers, the sum of the column and row values would not match the numbers on the keys, right? I mean, the 7 key would be a column value of 1 and a row value of 9, giving us a sum value of 10. The value I assigned to that key does not match what is written on the key, right? But we don't care. We are simply trying to detect whether any particular key has been pressed, and we will designate a specific value to each button. After all, you could cover over these buttons with a sticky paper and print custom meanings on each key. You can customize your keypad. I don't know, maybe you want Egyptian hieroglyphics instead. The Arduino is dum-dum-dum-dum. It doesn't know, nor does it care. It just wants you to give it a number. Now, with our row and column values, these would be the sum values that we would get for each button. One more technicality to consider before we proceed. Take a close look at your Arduino board, specifically pins 0 and 1. Notice they show that these pins are used for transmit and receive. So these are typical I/O pins that you can set up and use, but if you are using serial communication of any kind, those pins are the serial port. It's the same on the PIC. There were specific multi-purpose pins that were connected to the serial port. So if you are using serial communication, then obviously you can't also use the same pins for digital input or output, or pulse width modulated signal, or whatnot. So because we are going to use the serial monitor, we can't use either of those pins. So I'll wire in my keypad connections starting at pin 2. Now, you guys are getting better at your programming skills, so I want to make a suggestion here. As I wire up my keypad to the Arduino, the first 4 wires are the columns, which will get wired to pins 2, 3, 4, and 5 on the Arduino. Now, to make my programming a touch easier, I will use the Arduino pin numbers for my column values. This way, when I address pin 2, my column value will also be 2. So pin 3 gives a column value of 3. It is strictly to make programming easier. So doing this, my values for the columns and rows would look like this. Columns 2, 3, 4, and 5. And then the row values start at 6, increasing in value by 4 for each row. So the matrix values would look like this, the sum of each column and row value. So after hooking up the columns to pins 2 through 5, we'll hook up the rows to pins 6 through 10. We'll set up pins 6 through 10 as pull-up inputs to take advantage of those internal pull-up resistors and save ourselves a lot of wiring hassle. So this means we need to pull down our input pins to indicate the button has been pressed. How do we do that? We will initially set all of the column pins to high. When we scan or strobe pins 2 through 5, the columns, we will strobe each one with a low. So let's say I'm pressing the 9 button, which is connected to the Arduino pin 7 via the row connection. Pin 7 is being held high by a pull-up resistor. So if I press the 9 key and we strobe pin 4, which is column 3, with a low, it will pull pin 7 low. Bingo. If we didn't have that internal pull-up resistor on the Arduino chip, we'd have to wire power and a resistor to each one of the columns. Look at all the wiring we're saving. We just connected the wires direct out of the connector tab, straight to the Arduino's connections, and voila, we are ready to rock. We now just program accordingly. So let's build our code. You can download this in the download section, but I would strongly encourage you to actually type it out yourself instead of just copying and pasting. So we'll start off declaring a couple of integers that we'll use. The row value, which starts off at 6, the value of the first row, and the key value, which starts off at 0. The key value will be the sum of the column and row values from a key reading. We set pins 2 through 5 as outputs and pins 6 through 10 as input pull-up. What the heck, let's set pins 2 through 5 high, because we need to start those off high, and then we'll strobe them individually as lows, right? So we're going to spit out our reading onto the serial monitor. So also in the setup function, we will put in serial begin 9600. Down in the loop function, we now build our routine for scanning the keys and calculating our key value. Our columns are already set high, so we build a for loop, which will strobe pins 2 through 5, incrementing the count by 1 in each loop. We send out a low on the first column, which happens to be connected to pin 2. We then enter a second for loop, which steps through the rows, the row pins of 6 through 10, incrementing by 1 in each loop. The row value also increases by 4 each time it goes through the loop. It then performs a check to see if the current row we're on is reading low, indicating a key press on that row. If it detects a low, then it adds the row value and the whatever number our column is at, because our column number also happens to be our column value. And thus we get the key value. Notice here that I'm running a for loop within a for loop. It's a sub-subroutine. So once our sub-subroutine has hit a count of 10 on our row, the row scanning for loop ends. So we reset the row value to the start value of 6. We set the current column to a high, then go back up to the for loop, which increments to the next column. It then runs the row scanning all over again, with the next column being held low. Once it has completed this cycle of scanning all the rows in each column, we then print whatever value our key value was to the serial monitor, reset our key value, reset our row value, wait 100 milliseconds, and then go back and do it all over again. You may have noticed I performed no key debouncing here. And this is because all of these instructions take time. And thus, because it's so slow, it typically takes more time to read the keys than the duration of any key bounces. So, wire up your keypad to your Arduino and either flash this sketch or write your own and check out what happens when you press the keys. You'll notice that if you press more than one key, you'll get a 0 reading. Bonus points if you can figure out why. If your numbers are a little wonky, first check the wires between the keypad and the Arduino. It's easy to get two crossed. Next, check your code and make sure everything is kosher there. I have several challenges that I know you can do, should you so desire to push yourself forward. You can add some code that interprets the key values, and instead of printing the key value on the serial monitor, you could instead print out what is actually written on the key you pressed. Or you can add to your code and circuitry with some different colored LEDs. Program it so that when you press, say, the 9 key, the blue LED lights up, and when you press the F1 key, the red LED lights up. So, something like that, just to challenge your thinking and programming skills. Or hook up your servo motor to your Arduino and have it turn to specific positions depending on which button you press on the keypad.